more point, a shortcut for calculating the value, the expected utility of a game. Let's first consider what the expected utility of a row choosing R1 is going to be given columns half of the mixed strategy. If row chooses R1, then on 1/3 of the plays, that is when column chooses C1, row's going to end up losing -2. And on 2/3 of the plays, that is when column chooses C2, row is going to end up gaining 1. Okay? And if we do the math here, we're going to see that these wind up to equal 0. -2/3 plus 2/3. Okay? Now consider this. What's going to be the EU of R2? Well, the EU of R2 will be a value, the 1/3 of the time that column will choose C1 times the value of 6 for row, plus the 2/3 of the time that column will choose C2 times the value of -3 for row. That is 6/3 plus -6/3. That equals 0. And I bet you can imagine what the value of column choosing C1 giving row choosing this strategy is, and what the EU of column choosing C2 given the strategy is. You can work them out. They're both going to wind up to be equal 0. Because remember, it's an optimal solution. By column playing his or her part of the optimal solution, row's value is going to be the same on playing of either of these particular strategies, and similarly for column. So the easiest way to calculate the value of this game is to just simply calculate the value of one of the rows or one of the columns, because you know they're going to wind up being equal. Otherwise, this would not be an optimal solution, and one of the players would have reason unilaterally to switch his or her strategy to a different strategy. So the shortcut for calculating the value, the expected utility of a game involving a mixed strategy, once you've got the right mixed strategy, is just calculate it for a single row or a single column, because you know the expected utility of all the rows and columns are going to be exactly the same.